Imagine, just for a second, a world where every single calculation, every big multiplication problem, every division, it all had to be done by hand.
Yeah, just pure manual labor. Tedious.
Incredibly tedious, hours, maybe days, just lost crunching numbers. But what if I told you that way back, over 350 years ago, there was this brilliant mind, almost forgotten now, who didn't just figure out how to automate that, but actually dreamed bigger, like machines that could think.
It's amazing how much we take for granted now, isn't it?
Mhm.
You know, our phones, laptops, computation's just effortless.
Right.
But getting here involved these massive intellectual leaps.
Yeah.
And this individual, his work wasn't just about, say, faster math. It laid down some really core concepts for modern computing, even AI.
Yeah.
Understanding him, well, it's like uncovering the roots of our digital world. It really shows why those origins still matter.
Exactly. And that's what we're doing today. We're taking a real deep dive into Gottfried Wilhelm Leibniz, specifically his incredible invention, the stepped reckoner. We're going to look at who he was, this visionary figure, what exactly he built, how it actually worked, why it was such a huge deal back then.
A monumental leap, really.
Totally.
Yeah.
And how its legacy, maybe surprisingly, stretches all the way to the devices you're probably listening on right now. The goal is for you to walk away thinking, wow, I didn't know that, and really get the origins of computation.
Sounds great. He's a fascinating figure.
So let's start there. Leipzig, Germany, 1646. That's where Leibniz was born. And calling him a polymath, well, it almost feels like an understatement.
It really does.
Philosopher, mathematician, logician, diplomat, inventor. The list goes on. You might know his name from the whole calculus thing, right? Co-inventing it alongside Newton, completely independently.
Which is just staggering in itself.
Absolutely. But maybe even more relevant for us today is his work on binary logic, the zeros and ones. That's the language of computers. He was thinking about this stuff centuries ahead of his time, really setting the stage.
And what's so interesting about Leibniz is how all these different fields, philosophy, math, logic, they weren't separate boxes for him. They all connected.
Oh, so?
Well, his philosophy, for instance, he was obsessed with this idea of a universal characteristic, like a perfect symbolic language that could basically solve any argument through logic. And that directly fueled his desire to mechanize reasoning.
Ah, okay, so the machine wasn't just for numbers.
Not in his grand vision, no.
Yeah.
And even his adoption of binary, just using 0 and 1, it wasn't purely mathematical. He saw a kind of theological beauty in it, too, like 1 representing God and O representing nothingness, the idea that everything could spring from those two. It shows how his big abstract ideas really drove his practical inventions.
Wow. Okay, so that leads us to the practical invention. 1672, he builds the stepped reckoner. You said it wasn't just about faster math. What made it so revolutionary compared to what existed then?
All right, well, the big thing before him was Pascal's calculator, the Pascaline, from 1642. A brilliant machine for its time, but it could only really do addition and subtraction. If you wanted to multiply or divide, you still had to do it sort of manually, repeating the additions or subtractions over and over using the machine. Leibniz's stepped reckoner. This was the first machine ever that could handle all 4 basic operations: addition, subtraction, multiplication, and division,
Automatically. How?
It mechanized the complex stuff. Before, a human calculator, would have to manage all those repeated steps. Leibniz's machine took over that process. It was a massive conceptual jump in automation.
That is a huge leap. So how did he actually make it work? What was the clever bit inside?
The absolute core innovation was this component he designed called the stepped drum. We often call it the Leibniz wheel now.
Step drum. Okay, what's that like?
Imagine a cylinder, okay? But instead of being smooth, it has teeth along its length, 9 teeth specifically, but they're all different lengths. They sort of get progressively longer, like a staircase wrapping around the cylinder.
Ah, I think I can picture that, like steps.
Exactly like steps. So when you turned the crank to do a calculation, these drums would rotate. Depending on how you set the input dials, a gear would engage with a certain number of those teeth because of their varying lengths.
Right, so a longer tooth means a bigger rotation or engages more, something like that.
Precisely. It allowed the machine to represent and manipulate multi-digit numbers mechanically. So multiplication, while still fundamentally being repeated addition deep down, was now managed by the machine. The sequence, the repetition, it was handled internally by the mechanism, not by the person turning the crank, constantly readjusting things. It was like an early form of mechanical programming.
That's incredibly clever. So it wasn't just about saving time, was it? You mentioned his philosophy. He had bigger ideas. I remember that quote,
Yeah.
something like, "It's unworthy of excellent men to lose hours like slaves."
In the labor of calculation. Yes,
Right.
exactly. That quote gets right to his motivation. He saw calculation as drudgery that kept intelligent people from, well, more important thinking.
So the step reckoner was step one.
In a way, yes. He dreamed much bigger. He envisioned what he called a universal machine, not just for numbers, but for symbols, for logic itself. He imagined a formal system where you could break down any argument, any complex idea into logical parts, and then use a machine to calculate the truth, to resolve disputes.
Wow. That sounds incredibly modern, like the seeds of AI.
Absolutely. This desire to mechanize thought, to build machines that could reason, that's a direct line to the foundational ideas of computer science and artificial intelligence. He saw machines as tools to amplify human intellect, not just replace manual work.
Okay, so if the idea was so brilliant and the design, the step drum, was so clever,
Huh.
why didn't everyone have a stepped reckoner? What went wrong? Or what were the challenges?
Yeah, that's the crucial part. The concept was light years ahead, but the reality of building it in the 17th century was, well, incredibly difficult.
The technology just wasn't
Yeah.
there.
Exactly. The precision required for all those interlocking gears and drums was immense. It was complex, fragile, and really hard to manufacture reliably. In the end, only one full prototype was actually completed.
Only one. And did it work perfectly?
Not really. Reports say it was prone to errors, it could jam, and it struggled with carrying digits correctly in very large calculations. So in terms of being a practical, widely used tool, you'd have to say it was kind of a failure at the time.
But it still had an impact.
A massive impact, paradoxically. Because even though the machine itself didn't take off, the core design idea that stepped drum was revolutionary.
Ah, the concept lived on.
Precisely. Engineers and inventors studied it. It became a standard mechanism in mechanical calculators for, believe it or not, over 300 years. It directly influenced people like Charles Babbage, who we often call the father of the computer.
Wow, 300 years. That's incredible staying power for a design.
It really is.
Yeah.
And if you're curious, that original prototype of the one Leibniz oversaw, it's still around, it's preserved, and you can see it at the Gottfried Wilhelm Leibniz Library in Hanover, Germany.
Amazing. So that mechanism, the step drum, really did bridge the centuries, showing up in calculators right into the 1940s.
Yep, in various forms, it was a mainstay of mechanical calculation until electronic calculators finally took over.
But Leibniz's legacy isn't just that physical gear, is it? How do his sort of bigger ideas connect to our digital world now?
Oh, absolutely. His influence goes way beyond the mechanics. Think about his work on binary numbers, the zeros and ones.
The foundation of everything digital.
Everything, every computer, every smartphone, every piece of software relies on that binary system he championed and formalized. And his ideas about symbolic logic, about creating formal systems for reasoning, those are fundamental concepts in computer science and programming and algorithm design and AI development.
So we're literally using his ideas every day.
Constantly. Whenever you interact with a digital device, you're interacting with the legacy of Leibniz's thought. That's why he absolutely deserves his place as one of the great grandfathers of computer science, right up there with Babbage, Ada Lovelace, Alan Turing. His abstract thinking laid the groundwork for our entire digital reality.
It really puts it in perspective. So summing it all up, Leibniz wasn't just some guy who built an early calculator. He was, in a way, a prophet of the digital age.
That's a good way to put it.
His vision of machines that could handle logic, his foundational work in binary, those ingenious mechanical designs, you can really trace their echoes through, well, everything digital today. Computers, code, AI.
It's quite profound when you think about it. And it makes you ponder, doesn't it? Given Leibniz's dream of freeing up excellent men from the slavery of calculation with his universal machine.
Yeah.
Well, what are we being freed up for now? Thanks to the incredibly powerful descendants of his ideas. What new human potentials are unlocked when machines can not only calculate but reason and learn in ways Leibniz could only dream of? What comes next?
That is a fantastic question to leave us with, something for all of you listening to think about. What does come next? Continue your own deep dives, stay curious, and we'll catch you next time.